Let's begin with integration using algebraic substitution. Back before we have been integrating in standard format. Sin ax cos ax, okay, exponential ax, then ax, and the likes. Now, what if we don't have, what if the form they give us is not in this format? Let's take, for instance, we are asked to integrate cos 3x plus 7 dx. Now, if we look at this, cos 3x plus 7 dx is not a standard integral of the form. Thus, an algebraic substitution is to be made. So we can reduce this term and say that let u be equals to 3x plus 7. Now, if u is 3x plus 7, we can evaluate du dx, and du dx in this case is 3. Now, coming back to the question again, we have cos u because we have made the substitution already. Now, if we have cos u, if the variable we are integrating with is u, then our differential with respect to must be u. Therefore, we have to make the x du. So from here, let's make du subject to formula. Sorry, dx subject to formula. Therefore, dx is equal to du divided by 3. So we substitute the x into this, and we'll have du over 3. Now, this is equivalent to 1 over 3 cos u du. Bringing the constants out, we have it to give us 1 over 3 integral of cos u du. Now, this is a standard integral. We know that integrating cos will give us sine, and this will give us 1 over 3 sine u. Since this is an indefinite integral, we'll have plus c. Now, with this done now, we now substitute back our u. Our u is 3x plus 7. Then we substitute it back, and we have 1 over 3 sine 3x plus 7 plus c. Let's try another example. Let's evaluate the integral of 2x minus 5 raised to the power 7 dx. Now, we are familiar with using 2x minus 5 raised to the power 2, where we can just multiply it 2x minus 5 by itself 2 times. But do we have to go ahead and multiply it by itself 7 times? However, we can just use substitution method. So we say let u be equals to 2x minus 5. Then we can evaluate du dx, and that will give us 2. Then we can evaluate dx, making dx equal to the formula we have du over 2. Coming back to the question, we represent it now by u. We change the variable x to variable u. So this will become u raised to the power 7. And our substitution of the x is du over 2. Now this is integral of 1 over 2 u raised to the power 7 du. And this is 1 over 2 integral of u raised to the power 7 du. Now this is a standard integral, and this brings us back to the integration of ax raised to the power n with respect to x, which will give us ax raised to the power n plus 1 divided by n plus 1 plus c. Applying this here now, we have 1 over 2 multiplied by u raised to the power 8 over 8 plus c. So this gives us 1 over 16 u raised to the power 8 plus c. So therefore, we have to substitute our u back. Substituting our u back, we have 1 over 16 into 2x minus 5 raised to the power 8 plus c. Let's take another example. We are asked to evaluate the integral of 4 divided by 5x minus 3 with respect to x. Now, this is similar to integrating 1 over x with respect to x, and this will give us ln x. So bringing it down, we can say let u be equals to 5x minus 3. So we can evaluate the u dx to give us 5, and making the x to formula, we have it to give us du over 5. Now we can substitute our terms, making it in terms of u. That will give us 4 over u multiplied by du over 5. Dx is du over 5. And this will give us 4 over 5 integral of multiplied by 1 over u du. And this is this is 4 over 5 integral of 1 over u du. Now we call that integrating 1 over x dx will give us ln x. Therefore, integrating 1 over u du will give us ln u. So plus c, because it's indefinite integral. So we substitute our u back, and this will give us 4 over 5, then 5x minus 3 plus c. Let's take another example. Let's integrate 2 exponential 6x minus 1 with respect to x. So we are familiar with integrating exponential ax with respect to x to give us 1 over a exponential ax plus c. Now, to make this in form of standard form, we take our substitution of u to be 6x minus 1, then du dx is equals to 6, and the x is equals to 6 du over 6. Therefore, this will become integral of 2 as a constant exponential u, and our dx is du over 6. So we can write this as 2 over 6 integral of exponential u du, and similarly this gives us 1 over 3 integral of exponential u du. Integrating exponential u, we will have exponential u, so this gives us 1 over 3 exponential u plus c. Then we substitute our u back as 1 over 3 exponential 6x minus 1 plus c. Now, what if this question is now turned into a definite integral? Let's say we are asked to evaluate the same question, 2 exponential 6x minus 1 dx from lower limit 0 to upper limit 1. We know that when we integrate 2 exponential 6x minus 1 with respect to dx, we'll have this. Therefore, when we now have to include upper limit and lower limits, we will have 1 over 3 exponential 6x minus 1, upper limit 1 and lower limit 0. 1 over 3 is a constant. It can be brought outside, so that's 1 over 3 exponential 6x minus 1 from 0 to 1. So we substitute our lower limits and we substitute our upper limits. So that's 1 over 3 exponential 6 into 1 minus 1 minus exponential 6 into 0 minus 1. And this will give us 1 over 3 into exponential 5 minus exponential minus 1. And this will give us 49.35. Let's take another example. We are asked to integrate 3x into 4x squared plus 3 raised to the power 5 with respect to x. Now, taking a look at this question, we cannot go ahead and multiply 4x squared plus 3 by itself 5 times. It will become so lengthy. Therefore, we can make a substitution of u to be equals to 4x squared plus 3. Therefore, the u, the x, will give us 8x. And our dx, making the x subject to formula, we have it to be du divided by 8x. So let's rewrite the question using variable x, using variable u. So we have 3x. Then we made a substitution of 4x squared plus 3, and that will give us u raised to the power 5. And our dx is now du over 8x. Now with that done, we can see that the x and this x will nullify each other, and we'll be left with 3 over 8 integral of u raised to the power 5 du. And this will give us 3 over 8 multiplied by u raised to the power 6 over 6 plus c. Simplifying further, we have 1 over 16 u raised to the power 6 plus c. Now the next thing to do is to substitute our u back. And substituting our u back, we have 1 over 16 into 4x squared plus 3 raised to the power 6 plus c.